In this example, we're going to investigate congruence modulo ideals in the polynomial ring over Z. And here we have an ideal. It's the principal ideal generated by 6. So just a quick reminder, this is the collection of all polynomials that are a multiple of 6. So 6 times a polynomial. In particular, what this tells us is to be in this ideal, this is a collection of polynomials with coefficients divisible by 6, because all of the coefficients are 6 times something. And if all of the coefficients are divisible by 6, you can factor out a 6. All right, so that's our ideal. And we're going to investigate congruence modulo this ideal. So I claim a couple, I'm going to claim a couple things. At the start, I'm going to just argue that 9x plus 6 is the same as 3x plus 6. Now what this is saying, again, this part here, this is the ideal. This is an ideal. This is the same ideal. And this is ring element. And this statement says the following. This translates to the difference between 3x and 9x is in the ideal generated by 6. And that's something we have to investigate. So I'm going to put a question mark here. Okay, so 3x minus 9x is, of course, negative 6x. And that's 6 times negative x. Or you can see that here the coefficients are multiples of 6. Is a multiple of 6 because it's 6. In particular, this is certainly in the ideal generated by 6. And so, where's my gold? This is certainly true. Because the difference between our elements is in that ideal. Okay, so let's do another example. Let's look, for example, at 9x and 3. So is it true that 9x plus 6 is the same as 3 plus 6? Let's put orange here. Well, this would mean that 3 minus 9x is in 6, which means that 3 minus 9x, I'm not going to put the arrows, it means that 3 minus 9x is a multiple of 6. But that's clearly absurd, right? Because this would tell us that 3 and 9 themselves are multiples of 6. And this is not true. So no, these are not equal. Because their difference is not in the ideal generated by 6. That is, the difference is not a multiple of 6. So, sorry, it doesn't have coefficients that are a multiple of 6. So, what does it mean to be congruent modulo here? So what is congruence? With this toy example, in this ring Z adjoint X. Well, Px is congruent to Qx if and only if Q minus P is in 6, if and only if the coefficients of the difference are multiples of 6. Okay, so that's the criteria for being congruent. You take the difference of coefficients, corresponding coefficients, and you see if they're multiples of 6. And that's all congruence modulo this ideal means in this ring. And so, for example, 9x squared plus 12x minus 32 is congruent to 21x squared minus 38. Oops. Because the difference in coefficients, well, let's look at the x squared coefficients. 21 minus 9 is 12. Check. So the difference in x squared coefficients is a multiple of 6. 0 minus 12 is negative 12. Check. Difference in the x coefficients is a multiple of 6. Negative 38 minus negative 32 is negative 6. It's also a multiple of 6. So these are congruent modulo 6. Whereas something like 9x squared plus 12x minus 32 plus 6 is not equal to, 5x squared plus 12x minus 32. Although the constant in linear terms, their difference is 0, so that's certainly a multiple of 6. It's 6 times 0. The quadratic terms, 9x squared and 5x squared, 9 minus 5 is 4. 4 is not a multiple of 6. All right, so that was sort of a long example with the ideal generated by 6. Let's do another one. Let's do the same ring. Let's change our ideal to the ideal generated by x, which is a collection of all x p of x, where x is where p of x is a polynomial. Or this is just all polynomials without constant term. So let's take a moment and let's investigate congruence modulo the ideal generated by x. Okay, so what would it mean that p of x plus x is equal to q of x plus x? What does this mean when if we were to write this down? Well, it means that the difference is in the ideal generated by x, which means that the difference, well, to be in here, you have to have no constant term. So the difference has no constant term. And that's the only condition. The only condition is that the difference between the polynomials has no constant term. But what does it mean when we subtract two polynomials and there's no constant term? It means that the constant term of p, the constant term of one of them, is the same as the constant term of the other. That's what it means. So as an example, 9x squared plus 12x minus 32 is congruent to 21x squared minus 32 plus, is congruent to 21x squared minus 32 because, so here's my p and here's my q, they have identical constant term. So since they have identical constant term, they are congruent, and that's all we need to check. Whereas something like 9x and 3 are not congruent, put my gold mark here. They're not congruent because the constant term of q is 3, whereas for p it's 0. The constant terms don't match. So something that you could think about is we also had a certain ideal in the last section. So a question for you to think about is, what does congruence modulo the ideal generated by 2 and x in z adjoint x mean? Namely, if I were to give you two polynomials, how would you be able to instantly tell if they were congruent modulo this ideal?